Hello, welcome back on my YouTube channel. Welcome back on Physics Corner. Uh, I have video, this video about paper one, multiple choice question on October-November 2020, and I already posting the part one. You might to check it, and this is part two. In the part one, we have 10 numbers here. Number 1 until number 10, and on this video I try to uh, see you about number 11 to 20 maybe, yeah. Let's check it. uh, Actually this is script being uh, what I explain with my students, and I make it into video. Okay, let we start from number 11. The diagram show ballistic pendulum. A pellet of mass m small n traveling speed u hits a stationary block of mass m capital. The pellet becomes embedded in the block, causes the block to move its speed v immediately after the impact. When the pellet of mass 2m traveling speed 2u hits the block mass 2m, what the speed of the block immediately after the impact? Neglect the small increase in the mass block as the pellet mass adding during the collision. Okay, we start from this, yeah. When this one, small f hits with the velocity v, and then capital M, the block, yeah, at the rest equals to after m bit, you're adding m small and m capital, this one, times v, v after collides. And we said this is equals to v equals to m divided m capital plus m small times v. Then if we have mass pellet is 2m and speed 2u hits the block 2m, how much velocity uh, in v, yeah, in v. So we can say this is same thing, 2m plus times 2u plus 0 equals to 2m plus 2m small and capital times v. We find this one, so we can say this like for mu 2m plus m, so same thing with this one, yeah. So check, this is like two times, yeah, 2 times of velocity, this one, yeah, this is two times, yeah, 2 times of v, yeah. So the answer is 2v, yeah. Okay, I hope you understand what this. Then we go to number 12. A rigid circular disc of radius r has center at x. A number of forces of equals magnitude f act at the edge of this. All the forces are in the plane of the disc. Which arrangement of force provide a total moment of magnitude to fr about x? Yeah, actually, directly the answer is A, because the moment is, this is F times R, and then also this is F times R, and one direction circle, yeah, one direction circle. So like plus, yeah, FR plus FR. What about this one? This only F times R. Yeah, this only F times R, only one. But this one, this is 0 because in opposite direction rotation, yeah. This is on anti-clockwise and this is clockwise. So FR negative FR becomes 0. How about this one? This one like F times R plus F times S minus F minus R, so equals to FR. Yeah, FR. So the answer is A. Number 13. The diagram shows a uniform beam PQ. The length of the beam is 3.0 meter and weight is 50 Newton. The beam is supported a pivot 1.0 meter from NP. This a load of W hung from the P. The beam is in equilibrium. What the value of W? W is hung from the end of P. This, since we have weight is 50 Newton and the distance from the P to weight is 3.0, so we need only distance about pivot to the weight. So because this is length of PQ 3.0, so this is a half of 3.0 is 1.5. So from pivot to 50 Newton is 0.5. We use total torque equals to 0. So same thing, W times 1 equals to 50 times 0.5. W times 1 equals to 50 times 0.5. Yeah, so W is 25 Newton. Yeah, answer is A. Then what question 14? In a high wire circus arc, a man of mass 85 kg is standing at rest at the midpoint of wire. The wire on either side of man is at angle of 20 degree to horizontal. What is the tension T in wire? I think it's just about how to splitting force on the x axis or on the y axis. On the x axis we have T cos theta or T cos 20 on the left direction, and on the right direction is T cos theta, and then this it will be become to 0. Yeah, T cos theta minus T cos theta, so there is no force on the horizontal axis. And we have T sin theta for two wire. Yeah, so T sin theta times 2 on the y, positive y, and then on the negative y we have weight is 58 kilogram times gravitational acceleration. This, yeah, so 2 times sine 20 degree equals to W, yeah, or T equals to 85 times 9.8 mass times gravitational acceleration divided 2 sine 20. So we get about 1200 Newton or 1.2 kilo Newton. Yeah, answer is C. Okay. Question 15. A cylindrical block of ice of cross-sectional area is 12 meter square is floating, partially submerged in the sea. The density of seawater is 1020 kilogram meter to the power negative 3. A polar bear of mass 400 kilogram steps onto the block of ice. Okay, the block of ice sink vertical distance d. What is the value d? We use a relationship between upthrust force and W. Upthrust force and weight of beer and this ice block. Yeah. Upthrust force is rho GV or rho G times A times D. Yeah. And then weight is mg. So D means mg divided rho GH. Mass is 400 and rho is 1020 times 12 is cross-sectional area. So we get 0.033 meter, or this is something with 3.3 centimeter. Yeah. Answer is B. Okay. Question 16. A ball is thrown vertically upward. Air resistance is negligible. Which statement is correct? The answer is A. We check. Yeah. By the principle of conservation of energy, the total energy the ball constant throughout its motion. Yeah. Since air resistance is negligible, so total energy is constant. Yeah. B. By the principle conservation of momentum, the momentum of ball is constant throughout the motion. Momentum is different since they have a direction of velocity is different. Yeah. So different position, different velocity, something with different momentum. So B is not correct. C. The kinetic energy of the ball is greatest at the greatest height attained. No. The greatest kinetic energy is when they start uh, move upward. Yeah. And then it will be decreases, and then on the greatest height is minimum kinetic energy. And then the potential energy of ball increases at the constant during the ascent. No, potential energy is decrease since they have decreases in sorry no no this increases a constant rate during its ascent. No, yeah. So the answer is A. Yeah. 17. A hammer with 10 joule of kinetic energy hits the nail and pushes 5.0 millimeter into the plank. Both the hammer and nail come to rest after the collision. What is the approximate average force that act on the nail while it's moved through 5.0 millimeter? This like we use work done. Yeah. Work done by hammer equals to kinetic energy of the hammer on the nail. Yeah. So force by hammer is F and 5.0 millimeter, yeah, as a displacement or distance. So we can say F equals to kinetic energy divided 5.0 millimeter. Yeah, we get 2000 Newton. Answer is D. Later you may check from mark scheme is it correct or no. Yeah, if you get something it's not correct, you may to texting on the chat box. 18. The change in gravitational potential energy delta E of an object of mass m when the moving through height delta h near the surface of the earth is given by equation so delta E equals to mg delta h. Which question is needed a part of derivation of this expression? Um, Kinetic energy a half mass times speed square, or moment equals to force times distance, or weight equals to mass acceleration free fall, or work done power time. All the relationship, all the equation is correct, but it's about equation is needed part of derivation of expression. This like um, uh, force, yeah, force as the mass time acceleration of free fall, not about moment, not about kinetic energy, also not about work done. Yeah, because this is mm, conservative of energy. Yeah. Uh, 19. A racing car has output power of 300 kilowatt when traveling at a constant speed of 60 meters per second minus 1. What is the total resistive force acting on the car? Uh, when the velocity constant, so driving force equals to the power divided velocity. Yeah, we just dividing about 300 kilowatt with 60 meters second minus 1. Yeah, we get 5,000 newton or 5 kilonewton. Then 20, a mass of 60.0 gram is suspended from the spring, and the distance from the bottom of the spring to the floor is measured to be 16.4 centimeter. The mass is replaced with a 100 grams mass of the distance from the bottom of the spring uh, to the floor. Now measured to be 12.6 centimeter. The spring obeys Hooke's law. Yeah, what is spring constant of spring? This is about Hooke's law. Yeah, Hooke's law is uh, this from F equals to Kx. Yeah, so K equals to F divided X. But we have 100 grams of mass and then 60.0 grams suspended spring. So it's like subtraction between 100 and 60, and we need to convert into kilograms, so times with 10 to the power negative 3. Yeah, so this divided times 9, and then x is 12 so 12.6 becomes 16.4. So 16.4 negative 12.6 becomes something. Yeah, finally we get the constant spring is 10.3 newton per meter, or 10.3 newton meter minus 1. So the answer is C. Okay, I think enough for part 2. We will continue part 3 for number 21 until 30. Later I will make it a video again. Thank you very much for you watching this video. Hopefully it can be help you. Thank you. Bye bye.